All right, we're back. This is Conic Sections. This will be called 10.2. We're going to be focusing not on parabolas like we did last time, but instead we're going to be focusing on the hyperbolas. So remember the sequence. We have parabolas. That's going to be this cross section whenever we're doing conics. Okay. We also have this cross section. This is the hyperbolas, which we'll be focusing on today. And then remember, there's two other ones to spell the whole word PHEC. So P, H, E, and then C. So E represents the ellipse, which is a slanted cross section. That'll be the ellipse, and then one that's perfectly horizontal and parallel with the base there. That'll be the circle. So let's see if you guys remember. What are the characteristics of a parabola? How can we tell a parabola based upon all these other ones? What do you think? Good. Parabola has one squared variable. And then how do we tell a hyperbola from all the other ones? Okay. Well, hyperbola, you're right, has two squared variables, but so does an ellipse and so does a circle. Okay, so how do we tell the difference between all of these? Because look, they all have the same characteristics of two squared variables. So the hyperbola is going to have two squared variables and also opposite signs. The squared variables will be opposite. Okay. And then over here, we know that these two guys, they're not going to be opposite signs, but they're going to be the same. So both right now, the circles and the ellipse are practically identical. Okay, so how can we tell the difference between an ellipse and a circle? Well, an ellipse is going to have different either coefficients or different denominators, or maybe both. Okay, and then a circle will be the same. Okay, and hopefully from last time, I talked about a radius. A radius of a circle is the same in all directions. So just think the radius is the same for a circle, so same over here. But an ellipse is kind of like an oval, you know, obviously. So then, see, the radius is not the same here. See, if the radius here is 5, the radius here is not going to be 5 for an ellipse. So that's why it's going to be different. Then maybe that's how you can try to remember. Okay. All right. So we're going to be identifying the focus of the hyperbola and writing the equations of hyperbolas for the enhanced portion for the to keep going with this. Okay. But right now I'm just going to hit you guys up again and make sure that we understand the difference of each of these. And I showed you guys this sheet last time, but I'm just going to run through it again because it's beneficial for you. Okay. So when it comes to a parabola, there's a couple things that we need to remember. Obviously, it's the one squared variable, but then also we need to know that we have two variations of these parabolas. We know that if the if the x is squared, then that means it's going to be either a happy face or a sad face parabola, and we have a focus and a directrix. Okay, and so these are the two ways that this type of equation can look. However, if the x isn't the squared one, but the y is the squared, then we have C or backward C parabola. So a parabola can also be opening up towards the right or opening up towards the left. Okay, so with that, that's what we need to remember when it comes to parabolas. And then also the a, these are all functions. This one is not a function. And then when it comes to the a value is how we find the distance to the focus using this formula here, where the absolute value of a equals 1 over 4c. All right, so hyperbolas. It's just basically a parabola, but then you got two of them. Okay, so notice there's a parabola this way and a parabola this way. Okay, maybe one way you can think about it is let's say that an ellipse, instead of drawing an ellipse like this, I'm drawing an ellipse like this. So notice that I did a parabola facing this way and a parabola facing this way. Okay, so where there's a center here. So instead of drawing then an ellipse like that, I'm going to keep the center, but I'm going to draw an ellipse going the opposite way. So see how this just kind of flips over this way? Okay, so here, like if I was to take this one, if I was to take this and then I was to rotate it this way, sort of, yeah, that doesn't really work, but you guys know what I'm talking about. Okay, let me see if I can grab this. Come on, get. What the heck? There it is. Okay. Okay. If that flips out that way, and then this one kind of rotates this way, and then flip. Gosh, there it is. Flips over this way. Then we have what's called a hyperbola. Okay. Now notice that this hyperbola is going up and down, and I just drew one that's going sideways, right? Going to the left and to the right. So when do we know when it's going to be a up and down one or a left and right one? Well, that's how you can, when you look at the equation, that's how you can tell. Okay, I'm going to show you right now. Okay, so we know two squared variables. We know that it has opposite signs. And so when it comes to the equation, you guys see how we have this a and this B, okay? And then down here we have the A and we have the B. So right now I notice that we know that it has opposite signs. So see how the negative is going towards the Y and the negative is going towards the X? So see how what changes here from this equation and this equation is that right here the X term is positive and down here the Y term is positive. So that's how you can tell if it's going to be an up and down one or a left and right one. Okay, so if the X is positive, then that means it's going to be growing in the X direction. Okay, and then if the Y is the positive one, that means it's going to be going in the up and down the Y direction. So it's going to be growing on the Y axis and decreasing in the Y axis. Over here it's decreasing on the X axis, it's increasing on the Y axis as it's going. Okay? Everybody kind of get that? All right, so in this case, the A term is neither bigger or smaller in terms of the B. Okay? So we have to kind of compartmentalize here. That's why these lines here, because you think completely different when you get over to an ellipse. Similar but different. Okay, so we got two squared variables, same signs, different coefficients, different denominators. Okay, so an ellipse, we can either have a horizontal growing ellipse or a vertically growing ellipse. So we have two different types of equations. It still has an A and a B, and basically that's just going to be our denominators. Okay, both of them are positive here. Okay, and I'm not looking at the minus sign in the middle. I'm going to talk about that in a little bit. Okay, but the X is positive, the Y is positive, X is positive, Y is positive. But what's different here is that in these equations, the A value is going to be the thing that's going to be the biggest. Okay, so out of these two numbers, whoever's the biggest, that's how we can tell which way it's going to be growing. So let's say if A is, hold on, let me, actually I could go like this. There we go. Okay. So let's say that A is 25, okay? Or let's say A squared is 25 and B squared is 16. So over here we have 25 and then over here we have 16. Okay? And so down here we have 25 and then over here we have 16. So that's how you can tell the difference between the two ellipses. And I'm going to go over this more in the next PowerPoint. So notice that the bigger number is underneath the X, so it grows further in the X direction than it does in the Y direction. So let's say that this would be 5, this would be 4. Okay, now if the bigger number is underneath the Y, then that means it's going to be growing more in the Y direction than it is in the X. Okay, and that's how you can kind of tell the difference, and I'm going to go into more detail with that. And then when it comes to circle, remember, two squared variables, same signs and same coefficients, same denominator. So really, a circle, this is the equation of a circle. When we draw this out, it's going to be the same direction in the X, same direction in the Y, and that's why it's a radius that goes all the way around the circle. In this case, you guys see how the 16 is the indicator on how far we go. So we went out 4, so if you just take the square root of the 16, then that's how you figure out what the radius is. Alright, so let's try real quick, a little bit of a review. What the feck is this one? Is it a parabola? Is it a hyperbola? Is it an ellipse or a circle? So what I think you guys should do is write this down. That's all messed up, don't worry about that. Is it a parabola? Does it have one squared variable? Boom. Yep, so it's a parabola. Make sense? Alright, try this. What do you guys think this one is? Good. We got one squared variable, so that means it's a parabola. Okay, now here's my question. Looking at both of these, you guys see how the X is not the one that's squared, the Y is squared, and over here the X is squared. So is this going to be a happy face, sad face, or C backwards C? Happy face, sad face, C backwards C. Okay, so looking at this, remember your A term is right here, so if this is positive, then that means that it's going to be a happy face parabola. Okay, then over here, this is going to be a C backwards C, and since this is positive, it's going to be going in the positive direction. So this one is a happy face, this one is a C. Okay, so if the Y is squared, then it's growing, it's on its side going this way. Okay, all right. What type of conic section is this one? Good, this is a parabola. Okay, now is this a happy face, sad face, a C, or backwards C one? So watch here, I'll show you this is the standard form for it. Is this a happy face, sad face, or C backwards C? All right, so since the x is squared, that's the types of quadratics that we're more familiar with. So that means it's going to be a happy face, sad face. And so since it's negative, it's going to be going down. Makes sense? You guys feel like you understand parabolas, hopefully? All right, let's move on. What the feck is this? All right, so here we have two squared variables, so we know it's not going to be a parabola. And then are these two squared variables, are they the same or opposite signs? Because if it's the opposite, then we know it's going to be a hyperbola. But since they're both positive, we know that it's not a hyperbola. So the parabola is out of there, the hyperbola, that's out of there. So it's either got to be an ellipse or a circle. So how do we tell the difference between these two? Well, the ellipse is going to have different denominators. Remember, because, oh, I don't know why that just did that. It's going to have different denominators because it's going to be growing more in one direction than it is in the other, okay? So if I look at this, coefficient is 1, the coefficient is 1, so those are the same. Denominators are both 1, so they're the same. So that means that this is a circle for question number 12, okay? Now, do you guys see this part on the inside? That means that, and we're going to talk about this a little bit more, but this is the displacement. And if you guys recall, whenever we, let's say if we took a parabola and it looked like this, you guys remember when we're finding the vertex, this would be 5 and then this would be -4. So that would be the vertex, and that means that the parabola would then be moved over here, shifted over 5 and then down 4, and then the parabola would be going like this. So the same thing's going to happen with these two parentheses when it comes to the circle. Instead of the circle being right around the origin, it's going to be moved over, shifted over 3 and up 1. And so now the circle is going to be over here. So really basic, and it's definitely manageable that you guys can do. Okay, but we'll talk about that next time. All right, question number 13. What the feck is it? As you guys are thinking about that, I mean, remember, parent functions are very important for understanding all of these different types of equations. So you really can't tell when it comes to a parent function, but this is definitely one of the conics, so it's a must be a motherfucker. That's what I would assume. All right, so parabola. Is it a parabola? Do we have one squared variable? Nope, not a parabola. Is it a hyperbola? We have two squared variables. Yes, okay, but are they opposite sides? Nope. Is it an ellipse? Are the coefficients or the denominators different? Which, yes. Do you guys notice that I'm not even looking over here? I don't even care about all of these, okay? I'm just looking at the squared variables. Since they're different coefficients, that means that it's got to be an ellipse. Okay? All right, so notice this. Do you guys see this ellipse? This is a clue to my displacement and how it's shifting, okay? In the x direction, it's going to be shifting to the right 6. Over here, it doesn't have anything. It doesn't have anything even with the y, so it's not going to be shifting up or down. Okay, last one here. What do you guys think? What the feck is it? All right, good. We have two squared variables. The two squared variables are opposite signs, so it's got to be a hyperbola. Makes sense? Good. I hope you guys are feeling a little better about that. Okay, so what I want you guys to do right now is I want you to, on a piece of paper, I want you to try these 4 questions. See if you can figure out what the feck they are. So you can pause the video or whatever, but question number 19, 20, 21, 22. Classify the conic section. That's how the directions are going to be. All right, so this one right here, we have two squared variables, so it's not a parabola. And they're not opposite sides, and we see that the coefficients are the same, so this would be a circle. Now I'm going to show you guys the graph of the circle. Okay, notice this is the standard form. Okay, we see that in the y direction it was shifted up 4, so the center of the circle is shifted up 4, and then this was moved over to 2.5, I guess, right there. Okay. All right, so the center of the circle is found from these values right here on the inside of the parentheses. And then the radius is found by taking the square root, okay, the distance from the center out to each side. Okay, now over here, this is question number 20. What the feck was this one? Well, we have two squared variables, same sign, but then different coefficients, so that means that that's going to be an ellipse. Here's the ellipse. Notice the standard form. We see that from the x direction, it shifted over to the right. Here, watch. I'm gonna put this over. So it moves over to the right 3, and then this is up 1. So this is where the center of our ellipse is found. Okay, so center is 3, 1 came from these two values right here. And then watch this. If I was to count the distance going out this way, we see that that's 1, 2, 3, 4. Okay, so underneath the x, if we took the square root of the 16, that's how we get the 4. Okay, and then in the y direction, if we go up here, we see that's 1, 2, 3, 4, 5, 6. That's 6. How do you guys think I got that value of 6? Well, if I took the square root of this side over here, then that's how I get the 6. So really, these things are pretty easy to graph, and we'll talk about that again a little bit more later. Okay, I already graphed this one. This is a hyperbola. We can tell because there's opposite sides. Now, hyperbola, there's a bunch of like weird stuff right here. I'm going to show you how we're going to do that in the enhanced portion. But this looks really confusing. But let me show you basically. Let me make it a little bit simpler for you so it doesn't look so scary. Okay, so first off, we see in the y direction we have to go up 2. So that's where the center is. In the x direction, there's nothing there, so then it's not moving to the left or right. Okay, then in the y direction, now if I was to take the square root of this 9, we see that that's 1, 2, 3. That's how I find my vertex. So I go 3 up and I go 3 down. 1, 2, 3. That's how I find the vertice of this first parabola. Because remember, a hyperbola is going to be a parabola and another parabola. Okay, so a hyperbola is going to have a center, and the distance going up to that vertex, that's going to be that's the square root of the number that's in the denominator there. Okay, it's going to be kind of confusing at first, but it's real basic. Do you guys see how they drew this box? That's not part of the graph, but that helps you graph it. Okay, because you make these asymptotes. So anyways, on the x direction, do you see how we have this 25? If I was to take the square root of that, that's going to be the distance 1, 2, 3, 4, 5 over here. So we go 5, 1, 2, 3, 4, 5 this way, and then from down here I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then they draw a line that goes like this and a line that goes like this, and this is how we graph our hyperbola. So basically it works like this. Like if I was going to start from scratch, okay, I find the center, which was at 2, okay, and then underneath the y direction, because it's positive, I know it's growing in the y direction, I go up 1, 2, 3, put a dot, that's my vertex. You go down 3, 1, 2, 3. Okay, wait, is that 3? 1, 2, 3, yeah. All right, and then in the x direction, I go over 5, so 1, 2, 3, 4, 5, right there, and then I go back 5, and then over here I'm going to go over 5, and I'm going to go over 5, and then I draw a dotted line, and then these are kind of like my asymptotes. Okay, so asymptotes for my hyperbola, and so the actual hyperbola is going to be like this, and then it's going to ride the line going out like this, ride the line going out like this. That's one of the parabolas of the hyperbola, and then the other one would be going like this. And that's how you graph a hyperbola. We'll go into more detail in the enhanced portion. Okay. All right. So 22 is the last one. What do you guys think this one is? We have one squared variable, so that means that that's going to be a parabola. Okay. All right. So that's it for this portion. But if you guys want to continue with the Math 3 Enhanced, then we'll move on. All right, so if you remember, with each parabola, a parabola has a focus, and the focus is on the inside of the parabola. Okay, so since we have a hyperbola, which is 2 parabolas, there's also going to be a focus on both of the parabolas going both ways. So if we were to basically to graph these, kind of like what I did in the previous slide, is that you have this center, and so there's going to be some distance that goes out to this will be our focus, okay? And then this distance will also go out to the focus, and those two distances will be the same. Now, just like with the parabola, remember with the formula for the parabola we used A equals 1 over 4C. That's for a parabola, okay? So this is not the same formula that we use here. Okay, so since we're dealing with a hyperbola, there it is, okay. The formula to find the distance, the C distance, here we'll make it blue, okay. This distance right here, this C, which is from here to here, okay, from the center all the way to the focus, we're going to be using one that you're familiar with, which is a squared plus b squared equals c squared, where the c represents the distance from the center to focus. Okay, now since there's two focuses, you don't say focuses, you say foci, which is F-O-C-I, foci, or foci, or a lot of people pronounce it differently. Okay, so there is no directrix for this. All there is there's a center. Okay, so this right here is your center. There's a focus, there's a focus, there's two of them, and then we have the c distance, which is found by using that right there, a squared plus b squared equals c squared. So you might be thinking, or maybe asking yourself, wait, where does the a, where does the b come from? Well, if we recall with the format for regular hyperbola, remember this is h, okay, and then there's always minus, and then we have y minus h and k equals 1. And then do you remember what was underneath the denominators? We had an a squared and we had a b squared. So that's where we're going to use these two values to find the focus. Okay? Alright, so let me go over this PowerPoint here. So basically, it's saying that this is your standard form. Okay? So if I was to have this hyperbola, what we're going to do is we're going to like I said before, we're going to use the A and we're going to use the B in order to draw this little box, remember, which isn't part of the graph, but it helps us to graph it. Okay, so when we're dealing with a horizontal, let me move this down. When we're dealing with a horizontal hyperbola, remember, okay, we have two types of hyperbolas. If you guys are looking back at that sheet, the one that's, let me find it here. This one right here, okay? We have two different types of hyperbolas. We have either a horizontal one or we have a vertical one. Vertically growing one or a horizontally growing one. Now remember, if the x term is positive, then it's going to be horizontal. If the if the y term is positive, then it's going to be growing and it's going to be a vertical one. Okay? So if we're looking at this sheet, okay, and I'm about to write it down here in a second, but basically in this scenario, what's going to happen is whatever's underneath the x, this distance is going to be the a. Okay? Now over here, since this is the y, this distance right here is going to be the a. Okay, so whatever's underneath the y, that's how far you're going in the y direction if you take the square root of it. Okay? Whatever's underneath the x, that's how far you're going to be going if you took the square root of that. Okay? That's the x. And over here on the y, that's going to be the distance that we go out this way in both ways. Okay? So this right here is a, this right here is b. Okay? And then we draw the x, and that's how we graph these. Okay, so let me go back to let's see, this right here. So let's notice what's going on. I can tell that this is going to be a horizontal hyperbola, and the reason why is because the x term is the positive term, the y isn't. So the distance from here to the vertex is going to be whatever that a value is if I took the square root. So that's a. Now the distance that's from right here up, that's going to be if I took the square root of this. Okay, and all I'm going to do is just do it down there as well, and then I'm going to do it. I'm going to go a distance out to this point, and then I'm going to go up b, down b. And once you have that, then you draw these two diagonals. Okay, and that's how we graph our equation. Okay, so same exact thing, but when we're dealing with the and I'll talk about this more in a second. Okay. All right, so now if the y term is positive, then that means it's growing in the y direction up and down. Okay, so here, whatever's underneath the y, let me scroll down here. Whatever's underneath the y, this value, it's an a. I'm going to be going up the square root of that, which would be a, and then I'm going to be going over to the right b, over to the right b. Okay, so on the same thing, I'm going down from the center, okay, a, and then I'm going to be going over to the right b, over to the left b. Okay, and then once I have these 4 points, so here I'll make it in green. this point right here, this point right here, this point right here, this point right here. Then I draw a diagonal line going across, and those are going to be my guidelines as I draw the hyperbola. That's just when you're graphing it. Okay. Now, do you guys see all this like mumbo jumbo that's going on here? Do you see how it's saying it's pointing to this and it gives you a linear equation and it says it's a over b? So I just want you to think that what they're showing here is what is the slope of this line? So remember, slope is rise over run. So they're saying that the slope or the equation of this line is going to be up, starting from 0, up a over b. So that's your rise over run. Okay. Now if we go back to the previous one, this one's is going to be a little bit different because notice over here the rise is the b and then the run is the a. Okay, so this is kind of it's the reciprocal. So this one is going to be going up b over a. Okay. All right. So all this stuff on the side here that talks about the x-intercepts, y-intercepts, and then the vertices and the focus. I've already talked about the focus on how we find that. Okay, and we're gonna go in and we're just gonna do 2 examples, and that should be enough for you guys. Okay. All right. So this one, it says find the foci of the graph and then draw it. Okay. So it gives us our equation. So let's write down a couple things. All right. Number 1, I know that this is a hyperbola, and the reason why I know that this is a hyperbola is because I've got 2 squared variables and they're opposite sides. Okay. So we're gonna just kind of make a list. So I know that it's a hyperbola. All right, and then since the x value is positive, I know it's going to be a horizontally growing hyperbola. Okay, now since there's nothing inside with the x and nothing on the inside of y, that means when I go to graph this, here I'll put this down here. When I go to graph this, the center is going to be right at the origin. Okay, so the center of my hyperbola is going to be right here. So basically that point is going to be this guy right here. Okay? All right, so I want to find the vertices. The vertices are going to be this green point right here and this green point right here. Now if you guys remember, the vertice, the distance from the center to here is going to be whatever's underneath the x if we took the square root. Okay? So the vertex of 1 is going to be the a distance for this horizontal one. So this is your a squared, this is your b squared here. Okay, so if I took this and I was to go 36 and take the square root, we would get 6. So what I'm going to do is I'm going to go over to the right, 6. That's my vertice, and I go back 6. Bam. Okay, so I know my parabola is going to open up this way and open up this way. Now we want to know how wide is it going to be, or is it going to be skinny or whatever, and that's where this other value comes in. Okay, so from here, once we find the vertice, then we go up and we find this point, and then that's how we draw those 2 lines. So this one's saying 4. So if I was to take the square root of it, the b will be the square root of 4, which is 2. That's a 2. Okay, so from here I'm going to go up 2. And from here I'm going to go down 2. Okay? And these, I'll make them blue. These blue points right here are going to be where we're drawing our x. So from on this side over here, we're going to go up 2. And then we're going to go down 2. Boom. All right. Now, we're going to take this and we're going to draw kind of like an asymptote, a guideline here. Go all the way across. Guideline. Kind of running into my space here. All right, now we can draw my hyperbola. So notice, remember, double check that it's a horizontal one. So I'm going to start at the vertice, the vertex for this one, and ride the line. And that's how I graph a hyperbola. Okay, so we drew the graph. We kind of went backwards. Okay, so we drew the graph. Now it says find the foci. So remember, the foci, or the focus, right, of a parabola is going to be on the inside. So the focus is going to be inside here somewhere, and I want to know how far it is. Okay, so remember, we're going to use our formula. We're not using the absolute value of a equals 1 over 4c. That's for parabolas. Okay, different. All right, a different beast. Come on. A different beast gets a different formula. Okay, so this is not what we're going to be using. For hyperbolas, we're going to be using a squared plus b squared equals c squared. So we have our a and we have our b. We're going to add those together and then figure out what our c value is, okay? So a squared is 36, and then b squared is 4, okay, equals, and that's going to be 40. And if we were to take the square root of 40, let me calculate that real quick. Get an exact thing here. So 40, I took the square root, so that's 6.3. So 6.3. So that is my C value. So I'll make that red. C equals 6.3. So from the center, I'm going to go 6.3. So let's see. So 1, 2, 3, 4, 5, 6.3. That's where my focus is. That's one focus, and then if from here I go 6.3, so 6.3, that's where the focus is. Gosh, I don't know why that keeps doing that. All right, focus, boom. Okay, so we graphed it. We found the foci of both of the two parabolas. Boom, done. All right, let's try another one. All right, why don't we try one where we're doing, yeah, get out of there. Let's try one where we're doing where the y is positive, okay? So let's look at this. We know that the y is positive. We know it's a hyperbola already, okay? And it's going to be growing in the y direction, going like this and like this. Okay, let's see if we can come up with a couple things. Like number one, where's the center going to be? Where's the center of this going to be? All right, you think about that while I draw my coordinate plane. Coordinate plane like this. Okay. So, how do I find the center? The center is going to be whatever's on the inside with the y, whatever's on the inside with the x. That's going to be the shift, okay? But since nothing's on the inside, that means my center is going to be at 0, 0. Okay, so the center of this right here, this point right here, that's your center, okay? The center of this hyperbola is going to be right here at the origin. That makes sense? Okay, now, just real basic, to figure out where my vertex is, or my vertex for both of these, okay, I'm going to look what's underneath the y, and I'm going to take the square root of that. That's going to be my a in this case. All right, so the square root of 16 is 4, so I'm going to go up 4. 1, 2, 3, 4. Boom, that's where my vertex is. Down here, 4. 1, 2, 3, 4, vertex. Okay, now we know that it's going to be opening up and opening down, but we want to know how wide is it going to be. Is it going to be a super wide one? Is it going to be super skinny? What's it going to be? Well, that's where we grab this one. This is your b. Okay, so that's my b squared. So if I was to take the square root of that, that'd be 3. So from here I go over 3. 1, 2, 3. I go over here. 1, 2, 3. Okay, so this blue point, and then down here I go over 1, 2, 3. Over here, 1, 2, 3. All right, and then last thing is we take those points and we draw a kind of like an asymptote guideline here. From here, asymptote. Okay, and then double check that it's going to be a vertical hyperbola. And then we draw, let's make it blue. And then we draw our hyperbola. Ride the line, pass through the vertex, ride the line. Okay, ride the line. You can start from the vertex or you can start from the edge. And that's how you would graph a hyperbola. All right, now since we're here, why don't we just find the focus, because we're overachievers. So remember, a squared plus b squared will equal our c squared, and the c is going to be the distance up to our focus. So if I have 16 plus 9, that'd be 25. So c squared equals 25. So then c equal, oh, let me go back here. C equals 5. So then the distance going up is going to be 5. So let's see, if this is 1, 2, 3, 4, 5 would be where my focus is. Focus right there, and then I go down 5. That's where my focus is. And that's how you graph a hyperbola. All right, so if you guys want to give it a shot, I'd say try question number 2. I'll put up the answers here in a second. And then I would see if you guys got that. And then try some of these practice problems. Okay, so this is saying find the equation of the parabola that satisfies the given conditions. So these are kind of easy. Well, I mean they're a little bit different. I don't want to say easy, but it gives you the point, and it says come up with the equation. All right, so watch. I would draw the coordinate plane. We'll do question number 27. It says the foci is 5 and -5 on the x-axis. Remember, that's the x. So that means the foci is going to be 5. 1, 2, 3, 4, 5. That's one focus, and the other focus is 1, 2, 3, 4, 5. So if the focuses or foci are like this, that means that these parabolas are opening up to the side. That means that the x is going to be the positive one. Does that make sense? And then the y is going to be the negative one. All right, that's how I start this. And the hyperbolas are always going to be equal to 1 for their equations. Okay, then it says the vertice is 3. So that means 1, 2, 3. That's where my vertice is. So this is going to be 3, and then 1, 2, 3. That's where my vertice is. So then this guy goes like this and opens up this way and opens up this way. So remember, underneath the x, that's going to be the distance going here. So since it's 3, that's my a. So a squared would be 9. Okay. So the last part of this equation is we need to figure out what goes under here, which is the b. So we have the a, we have the b. I'm sorry, we have the a, we need the b, and we know what the c is. Remember, the c is the distance going out here. So if this, let's make it green. If this distance right here is the c, okay, and it says c is 5, we can start to kind of write this out. We got a squared plus b squared equals c squared. So we know c is 5, so that's 25. And then we know that a is 3, so that'd be 9. Now we can solve for the b. So we subtract 9 from either side, and we get b squared equals 16. So I put the 16 right there, and that's how you come up with the equation. Okay? All right, so all of these are just different ways. I would go back and look at the PowerPoint if there's things that you don't understand, like when it talks about the length of the transverse axis. Look at the PowerPoint. It's basically the transverse axis is the distance going all the way across like that. Okay? Give it a shot, and then check your answers after you're done. Okay? There's the answers. All right? Until next time, see you later.